Hello, welcome to Examguide Consult Limited. Today we'll learn mathematics, and in mathematics we're going to learn standard form. Okay, so we'll learn standard form today, and we're just going to look at the learning objectives of this class. By the end of the lesson, you should be able to define standard form, then solve problems on standard form basically. Okay. All right. What is standard form? What is standard form? Standard form is also known as scientific notation. It is a way of representing numbers, especially large numbers or very small numbers, as a product of a number between 1 to 10, excluding 10, like 10 as a number. And it has a power of 10. Okay, so imagine a very large number, okay, that is made up of like, let's say 20 figures, that is made up of like 50 figures, made up of like 100 figures. It will be so tedious for you to begin to write those 20 figures or 100 figures or 50 figures. So in order to shorten, to make it very fast, we can shorten the number of figures that that number has by this simple method of what we want to look at now, what we call standard forms. Okay? And we say standard form is a way of representing this large number or very small number or very large numbers, okay, as a product of a number between 1, 2, 3, 4, 5, 6, 7, 8 to like 9, okay, multiplied by the power of 10. So generally speaking, standard forms are represented as this. Let's say A being the number times 10 raised to the power n. Do you understand the point now? Okay, where A is the number from 1 to 10, okay, then n is equal to the number of figures, okay? The number of figures attached to that number, or we can say it is the index of the number. So let's assume we have 700. Okay, let's say we have 700 million. This is 700 million. Okay? Now, this 700 million is actually a very large number. You know, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, let's assume where you want to write this number is not as wide as how this thing can enter. Okay? You can shorten this thing to be counting the number of 0, 1, 2, 3, 4, 5, 6, 7, 8. You can say this is 7 times 10 raised to the power 8. Do you understand the point now? 7 times 10 raised to the power 8. At this point now, you have shortened this number. This number that is 1, 2, 3, 4, 5, 6, 7, 8, 9 is just 1, 2, 3, 4. Do you understand me now? So this is an example of what we mean when we say standard form. Do you understand the point now? So, two things you must know about standard form before we go ahead to look at some examples from our Examguide study app. We'll look at two things that you must know when converting or when dealing with issues around standard form. Okay? Now, it is before you get to where the number you're considering is. For example, okay, these 0, 0, 0, 0, 0, 0, 0, they are not numbers between 1 to 9. So you're looking at numbers between 1 to 9. So every other thing like 0 that are not significant or so, they are not considered. Do you understand the point? So when you are, two things you must know. Number one, For all real numbers, that is, for example, 5, 4, 2, example, all real numbers have an invisible decimal point at the end of it. So this is 542.0. That is what it means. Do you understand? So this kind of number can be converted to standard form. Do you understand the point now? So it can just be depending on where we want to move the 0 to. If we want to move to this place, it will now be 54. This point moves here and it becomes 0.2 times 10 raised to power. How many times it moves is 1. So 10 raised to power 1, but we can just put it as 10. You don't understand the point. If we want to make this point to move down here, okay, it will be 5.42 times 10 raised to power 2 because it moved 1, 2. Do you understand the point now? All right. So this is one. Look at another scenario. Let's say this 5.42 times 10 raised to power times 5.42. And we want to move this now to we want to move this one now to this side. So this will be 5.4.2 times 10 raised to power minus 1 because it moved once. That is what it means, that this thing still means what we just did now. Now see this. Now let's say this is moving from here. It's moving 1, 2. So this will be 542 times 10 raised to power minus 2. Do you understand the point now? Now the point I want to make is that when you are moving your decimal points in standard form, if your decimal point moves to the right, if it moves to the right, okay, if it moves to the right, what that simply means is that your power of 10 will be negative. So it means that power of 10 will be negative. Will be negative. Now, if it moves from this point to the left, if it moves to the left, power of 10 will be what? Positive. Do you get that now? That is why when we had something like this here, remember we had two scenarios here. When we had something like this here, where the point went back and went to the left or backward, when it went backward, the power of 10 is in positive notation. That is here. There, but when we moved this decimal to the right, that is forward. When we moved it forward, the power of 10 is in negative form. Do you understand? So that you must understand in standard form. When you move a decimal point in any number, remember decimal points are not only seen in decimal numbers alone. There are even the special number, even the normal real numbers we know, there is an invisible decimal point at the end of the number. So when you want to move that decimal point forward, if you're moving the decimal point forward, okay, the power of 10 should be negative. But if you're moving the decimal point backward or to the left, the power of 10 should be positive. So you must have to understand that, because we will have to take some examples on how to solve some questions on standard form, okay? Okay, so I think these are basically some of the things you need to know about decimal form, the basics of the things you need to know. So let's look at our Examguide learning app and get some past questions, get some questions on standard forms that was given in some exams, okay? So let's look at it. Okay, so let's look at the first thing we have here. They said we should express 0.00706 in standard form. In standard form. So we're asked to express that number in standard form. So we have 0.00706, and we are asked to convert it or express it in standard form. Remember, our standard form should have something like this. Should have an expression like, let's say A is the number that is between 1 to 9, remember, times the power of, n, which n represents the number of figures that you will count, or the index, or the number of figures you will count before you get to that number that is between 1 to 9. Okay? So, we are looking at this number because this 0 and this 0, they are not of concern to us. They are not significant here. We're looking at that number that is between 1 to 9 to use as the standard of expressing this number. So it means that our concern is to move this decimal point from this position to where we have 7. Now, we're going to move it 1. We move again. 2. We move again. 3. So this decimal point now has moved from this place to this point now. So this gives us this number to be equal to 7.06 times. Now, why we're bringing these times or this multiplication sign is because this number of times that this decimal moved, that's why it's bringing the times. So how many times did it move? So it moved 1, 2, 3. So we have this as 10 raised to power. Remember, we said when we are moving to the right, the power of 10 will be what? Negative. So this is 1, 2, 3. So it means that 3 will be negative 3. So this is the standard form of writing 0.00706. Do you get that? Okay. So it's going to be 7.06 times 10 raised to power minus 3. 7.06 times 10 raised to power minus 3. And that is option E, 7.06 times 10 raised to power minus 3. All right, let's go to the next one. The next one says we should express, so if you did not get this, you pay attention in this second one. Express 0.0070936. Okay? In standard form. So the solution. Write out the number 0.0007936. Okay? So let's see. Now, remember our point, our A is numbers between 1 to 9. Numbers between 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, which is the first number? That is 7. Okay, that's the first number we have seen there. So, this will move 1, 2, 3, 4. 4. So the decimal point is going out of this place, and everything here moves out to give us 7.936 times 10 raised to power. How many times did it move? It moved 1, 2, 3, 4. So this is minus 4. And that is the answer. Now, that's the answer. So if you look at your options, 7.936 times 10 raised to power minus 4. So this is the answer here. Option A is the correct answer. Now, before we go to the next question, you can as well decide to. Why I had to stop here is because if you check the options you have there, this is the option they have. You can decide to say 0.0007936. Okay, you can decide to say, okay, you want to convert it to standard form by converting it so that the number will become a tens. Do you understand me? You can decide to keep it at the tens or at the 100 or at the 1,000, whichever one you want to use, provided you know how to maneuver your the power of 10. That's index. Do you understand the point now? This is what I mean. You can decide to say, instead of stopping here, it stops at where we have 9 and 3. So this moves 1, 2, 3, 4, 5. Can you see that? So we decided to stop at 5. That is here. So this will be what? 79.36 times 10 raised to power what now? It went 1, 2, 3, 4, 5. So this will now be 10 raised to power minus 5. Do you understand me? Do you get that? All right, let's go ahead again. We can also say 0.0007936. Okay, we can set to say it is 1, 2, 3, 4, 5, 6. Do you understand? So this can be for us 793.6 now times 10 raised to power how many? 1, 2, 3, 4, 5, 6. Minus 6. Remember, it is going forward. That's why we are having minus index. Okay? All right. We can also have it as 0.0007936 now. And we say this is 1, 2, 3, 4, 5, 6, 7. This is where the point is now. And we can now say this is 7,936, okay, times 10 raised to power minus 7. Do you understand the point now? This is also, somebody may say, oh, then where is the point? Where did I put the point? Remember I said all numbers that do not have a decimal point have an invisible decimal point. Do you understand? So there is a decimal point after this 6. Or you can have it as, this number is still the same thing as 7936.0 times 10 raised to power minus 7. So, but there's no need of this 0.0 because we know 0.0 of any number is still that number. Do you understand the point? So, now, whichever way you want to, now if we had solved up to this point, you will check your options and you will discover that the answer is not there. Do you understand? So that is why we had to just, by standard, just stop at the first number. But what it means is that 7.936 times 10 raised to power minus 4, 79.36 times 10 raised to power 5, 793.6 times 10 raised to power 6, and 7,936 times 10 raised to power 7. They are all the same thing as 0. Are you with me? They are this, and this. They are just this number in different ways of writing them in standard form. Do you understand the point? All right. Okay, so let's move on and look at some other question. Let's look at the next question. This question says, which of the following numbers is the greatest? Good. Which of the following numbers is the greatest? So they gave us 5 numbers there, and they're asking us which of them is greatest. See what I want to do for you. I will write out all the 5 standard, all the numbers are in standard form. Look at them, just look at them again. 1.4 times 10 raised to power 5, 3.0 times 10 raised to the power 4. 2.3 times 10 raised to the power 3. 4. Okay, we will come back to this question. Let's solve a question that will ask us to convert to standard form for a number that will give us a positive index. When I teach you how to do that, we will now come back and do this. So this is number 3. Let's mark it. Okay, so let's look at the next one. Let me just look at good. Now let's look at the question. It says express 2,734,000 naira in standard form. Okay, 2,734,000 in standard form. So let's look at that form in scientific notation. Okay, in scientific notation. All right. So now our point. Remember, I said this is 2734. I'm removing all those commas. 0, 0, 0. Okay. So we want to convert this number to standard form. Now remember, our challenge or the problem we want to solve in standard form is to look for or identify where you have the decimal point. Where you have the decimal point. What we did here, we identified where we have decimal points. Okay? Now, but this number, look at it very well. There is no decimal point given to us here. But listen, I have told you, all real numbers, all positive numbers, all normal numbers, okay, they have invisible decimal points at the end of it. Do you understand the point? So there is a decimal point here. There is a 0.0 here. So just like 1 is 1.0, 2.0, 3.0, 4.0. But there is no need of putting all this 0.0 because we know that 1.0 is still 1. Do you understand? 2.0 is 2. 3.0 is 3. 4.0 is 4. Just like that. Same way, 2,734,000 naira 0.0 is still 2,734,000 naira. Thousand rather. So there is our 0.0 here. And this 0.0, what we want to do is we want to move it to the beginning of this number. Because if you look at the option, if you look at your options there, we have the point just after 2. Okay? So this point can be anywhere. It can be here, it can be here, it can be here, it can be here. But what we want to do now from the options we have there is this. We have to move this 1, 2, 3, 4, 5, 6. 6. 6. Now, once we move, so this means 2.7 now. 3, 4. These zeros don't mean anything anymore once we remove the decimal point from them, from where they are. Just like what we had here. We didn't write this 0 anymore. So this 0, they mean nothing. Do you understand the point? So, but remember they are counted. So they will still be there, but in the index of the number, in the power of 10. Do you understand? All right, so this will now be times. Remember, it's always in the power of 10. Now, what is the index I'm going to put here? Now, what it means is that we counted 1, 2, 3, 4, 5, 6. So the question is, that 6, will it be positive or negative? Will it be positive 6 or negative 6? Remember we said, when we are moving forward, negative index. When we are moving what? Backward, positive what? Index. So this will be what? Positive 6. So this will be raised to power 6. Is that okay now? So our correct option there is option D. 2.734 times 10 raised to power 6. So this is the correct option. Do you understand that? Now we can, like I said, why I decided to do this is because if you look at your options there, okay, so just always look at your option and know what they want you to do. Now look at this now. We can have this into B. If this point had ended here, it would have been, let's say, 2734000. This point moving 1, 2, 3, 4, 5, and stop here. So this would not have been 27.34. Do you understand? Times 10 raised to the power. How many times? 1, 2, 3, 4, 5. 10 raised to the power 5. It is still the same thing as this whole thing. Do you understand? Okay. If we had done let's say 2.2734000 and we did 1, 2, 3 to be 2734 times 10 raised to the power how many? 1, 2, 3. 3 zeros. Do you understand that now? So whichever standard you want to put it, you can put it. Do you understand? All right, so let's look at, I said we're going to look at, there was a question we skipped. I wanted you to have a knowledge of how to go back, how to count back, because we will be doing how to count forward. So because that question is about counting backward. So let's see now. So it says, which of the following numbers is the greatest? Which of the following numbers is the greatest? Number 3, number 4. So we have, the first one is 1.4 times 10 raised to the power 5. 1.4 times 10 raised to the power 5. The second one is 3.0 times 10 raised to the power 4. 3.0 times 10 raised to the power 4. The next one is 2.3 10 raised to the power 3. 2.3 10 raised to the power 3. Okay, the next one again, 4.3 10 raised to the power 2. 4.3 10 raised to the power 2. Why the last one? 9.7 10 raised to the power 1. 9.7 10 raised to the power 1. Or just 10, okay? But 10 raised to the power, let's see. Okay, so we want to know which of these numbers is the greatest. Like I've said, for me, okay, because of this power that is bigger than all of them, this should be the highest because they are all in the same decimal point, in one decimal place. So this should be the highest. The higher the power of any particular number, the larger that number. Okay? But then let's solve, let's assume, I may not be right, but I know it is actually, so let's solve it to know if what I've just said is correct. So now, remember, when we did this number, it gave us this, right? So something like this is almost as something like this, okay? Remember, this 2.734 times 10 raised to the power 6 is what this thing is 2734000, right? How I got that was to simply do, if you have this 2734, okay, was to do this thing now into 6 places, move it 1, 2, 3, 4, 5, 6. So 0 here, 0 here, 0 here, to give us this 2734000. Can you see? So what they want us to do here is just a reverse of something like this. We want to reverse this standard form to real number. Let's just change them to real numbers. When we have them as main or real numbers, we can know which number actually is the biggest or which one is the biggest. So this will mean for this one, 1.4, okay? It means that we will move this point how many times? 5 times. So this will mean 1, 2, 3, 4, 5. This point is now here. So we put our 0, 0, 0, 0. Do you understand me now? So this is just 140, 140, 000, 000. So this is 140,000 that I will have there. Sorry, 140. Is that okay? Then we'll have 3.0. And we are moving how many times? 4 times. So we're moving this point 4 times. 1, 2, 3, 4. So the point is now here. So we're adding 0, 0, 0 to now be equal to what? 3, 0, 0, 0, 0. You see that? We do the same thing for 2.3. 2.3. How many times are we moving? 3 times. So we're moving 1, 2, 3. So it is now here. So we're moving 1, we're moving 2. So this will now be equal to 2, 3, 0, 0. Can you see that now? 2, 3, 0, 0, 0. Now look at this now. This is 4.3. We're moving how many times? 2 times forward. Okay? So this will be 4.3. We're moving 1, 2. Meaning this is now where the point is. We are adding 1, 0 here. So this will be 4, 3, 0. The next one is 9.7. How many times are we moving? Just once. So this is 1. So the point now is now here. Okay? So this will be equal to 97. Is that okay now? So if you look at everything we have here now, 140,000 is the largest number, is the greatest number in all of them. So we say that 1.4 times 10 raised to the power 5, 10 raised to the power 5 is the greatest number in all of them, which is option A. Okay, which is option A. Which of the following is the greatest number? It's 1.4 times 10 raised to the power 5. Is that okay now? Okay. Before we look at the next question, let's look at like this. Like I said, it's just a reverse of this. We can still reverse this to be this now, right? Like 140, you will see that when we change 140 to a standard form, it will give us this exactly. Look at 140,000. And there's an invisible decimal point here. It moves 1, 2, 3, 4, 5. It moves 5 times. So this is equal to 1.4 times 10 raised to the power 5. Can you see that now? Because we moved backward and the power of 10 will be in positive. Okay? Look at for 30,000. 30000. So this is an invisible. We move 1, 2, 3, 4. So this is equal to 3.0 times 10 raised to the power what? 4, and so on. If you do that in everything you have here, it will give you the same thing that you have here. Is that okay now? All right, so let's look at some more examples. Express these in standard form. Express this in standard form. Okay. So we're having 1, 2, 3, 4 in standard form. So simple. Put a solution 0.00001208. Okay. So our concern is this decimal point. It moves 1, 2, 3, 4, 5. So we have 1.208 times 10 raised to the power. It moves forward. So it's going to be what? Negative index. 10 raised to the power 5. That is that for this. And the correct answer there is 1.208 times 10 raised to the power minus 5. So that is option C, the correct option there. Okay. Okay, we've solved this. Now they say express this in standard form. Okay, let's look at this one. This one we should express 6. Express 0.0000743 times 10 raised to the power 2 in standard form. So let's look at the solution to this. So we have 0.000743 times 10 raised to the power 3, to the power 2 rather. All right. So if you look at this number, you will think that it's already in standard form. This number is in standard form. No, it's not. It's still a very large, small number. Okay? As long as you have, remember standard form, where the point should begin is after a number between 1 to 9. But here we have 0 point, meaning that 0 is not up to 1. Do you understand? So that number is not in standard form. So our attention should be how to convert that first number to standard form. Okay. Of course, we have another number there, a number in power of 10, where we have 2 raised to its power, as its power rather. So what we need to do is to, first of all, convert that first number to standard form, this one. Okay, so this means this will be 1, 2, 3, 4. Okay, so this will be 7.43 times 10 raised to power 4. Remember, okay, 7.43 times 10 raised to power 4. Remember, we said if we are moving forward, we have our answer in negative, the power in negative. But if we are moving backward, like we did here, if we are moving backward, we have in positive, forward in negative. So this is simply 1, 2, 3, 4. 7.43 times 0 power minus 4, okay, times 10 raised to power 2. That is what that means now. Okay? Now, at this point now, we have 2 powers of 10. Okay? 10 raised to power minus 4 and 10 raised to power 2. So what do we do? Okay? We apply the law of indices, the multiplication law. When 2 numbers of the same base, okay, multiply themselves, you add their powers. Okay? That is one of the laws of indices. Okay? The multiplication law. Once you have 2 numbers of equal base, of the same base, this is base 10, this is base 10, this is power of 2, this is power of minus 4. But they have the same base, they are of the same number. So we do what? We bring out one of their bases, just one, and add their powers. Just one of them, since they have a common base, and we add their powers. So what that means is 7.43 times 10 raised to power minus 4 plus 2. Have you seen what we did there? I brought these 2, I just brought a common base here for them. Then I added their powers, minus 4 plus 2. So this will be equal to 7.43 times 10 raised to power minus 4 plus 2. Minus 4 plus 2 is simply minus 2. You're owing somebody 4 naira, you have 2 naira. When you pay the 2 naira, you still owe 2 naira. So this is minus 2. Okay, so we have successfully put this number, okay, in its correct standard form. Is that okay now? So the correct answer there is 7.43 times 10 raised to the power minus 2, option C. Okay, then we'll move to the next one. Express this in standard form. Express this in standard form. I think this is, you can do this now, okay? So that's what we're going to do. Just do this and drop your answer in the comment section, okay? Just solve this. Just solve your answer. Show me your workings. Maybe you can do explanation with a sentence if you can't put the mathematical figure there. So just solve this and put your answer on the comment section. Okay, 0.00724 in standard form. Do that. Okay, let's see if there's anything new that you need to know. This also do it. Express it in standard form. Okay, 0.00004. So you can also do that. Okay, express this in standard form too. So you are doing 3 things for me. Okay, 0.004532. Also in standard form. And let's look at the next one. Okay, let's look at this one again. Let's solve this one. Okay, standard form. Okay, solution. So we have 61782 in standard form. So this will be equal to, remember, for a real number like this, that is not a decimal number, there is an invisible decimal point here. So we're moving this decimal point backward. So we're moving it 1, 2, 3, 4. Are you with me? So this will be 6.1782 times 10 raised to power. Remember, moving backward, our index should be positive. So this will be 1, 2, 3, 4. So this will be raised to power 4. That is the answer of that. Okay? Yes, option E is the correct option. 6.1782 times 10 raised to power 4. Okay, so with this, you can solve questions that has to do with, standard form. Okay, just apply the principles I have given you here. Okay, know which question that needs the approach of a standard form principle. Once you know that, you can apply these principles we've learned so far and you get the answer correctly. Thank you so much. I'll come your way again.